Welcome to the section 6.2 notes. We're going to solve more trig equations today. No warm-up question for these notes. We're just going to jump right in. So I talked about this a little bit in the other video, but we're going to solve for all solutions, meaning there's no restriction on this angle. So we're going to have actually a variable in our answer. I'm going to do this in degrees. Doesn't specify. If it doesn't specify, I don't really care if you do degrees or radians. Just got to make it clear which one you're doing. So I'm doing this one in degrees. So if I add 1 to both sides, I get this. Divide both sides by 4. I'm going to get cosine squared theta equals 1/4. Now this is just like having x squared equals 1/4. I would take the square root of both sides, which would leave me with cosine of theta equals, now when you take the square root of both sides, you get plus or minus. Okay, I know the square root of 1 is 1. And then the square root of 4 is going to be 2. So I'm going to get plus or minus 1/2. So if I take the square root of 1/4, I get plus or minus 1/2. Cosine is going to be positive and negative in every quadrant. So there's going to be more than one possible answer. So I know cosine is going to be 1/2 right there and right there. Those are the positive ones. And then the negative ones would be right there and right there. Okay, remember, all students take classes or cast, whichever one you like best. You've got to be careful with how you write your answers. Now, to figure out what theta is, well, I'm going to first start with cosine of theta equals 1/2, or cosine of theta equals negative 1/2, because those are two separate cases. So theta equals the cosine inverse of 1/2. These are the ones that I did in black over here. Cosine's positive in quadrant 1 and 4. All right, so quadrant 1, if I just look at my normal reference angle, cosine is going to be 1/2 at 60 degrees, or theta is going to be, cosine of theta is going to be 1/2 at 300 degrees, if I just subtract 60 from 360. Now, over here, we have negative 1/2. So cosine inverse of negative 1/2, that's going to be 60 degrees short of 180, which is 120 degrees, or theta equals 60 degrees past there, which is 240 degrees. These are 4 answers, but these are not all of the answers, because you can continuously spin around the circle and continue to go since there are no restrictions. So there are a few ways you can write this. You can write each one, I almost wrote in radians. You can write plus 360k on all of these, but that is super inefficient. So I'm going to erase it and write a better answer anyway. That covers every situation, but you can also see that this plus that, or excuse me, 60 plus 60 is going to be 120. 120 plus 120 is 240. 240 plus 120 is there. So for some of these problems, you can actually just combine these answers a little bit. It's not always going to be super nice. Like if I wanted to, I could write 60 plus 60k. That'd be super short and convenient. However, 180 does not work. 360 does not work, and that would come into that part as well. But I know 60 plus 180 equals 240. If I do 240 plus 180, well, 240 plus 180 it is going to be, oh, pressed the wrong button. That's 420 degrees. Well, 420 degrees is just 60 degrees again. So that works. You could have theta equals 60 degrees plus 180k. That takes care of those two. And then you could have theta equals 120 degrees plus 180k, which would take care of those two. We should put a degree symbol with that 180k. This is like the most abbreviated way you can write the answer for this specific question. The one that I like the best personally, if you get cosine of theta equals square root of 2 over 2, or plus or minus square root of 2 over 2, I should say, you'd be able to just do 45 degrees plus 90k, because it happens in every quadrant, and it's always going to be one of the two. But for this one, because of where they land, if you just did plus 60, you're going to have 180 show up and 360 show up, which is going to throw things off. So this is the abbreviated way. If you want, you can just write 60 plus 360k, plus 360k, plus 360k for all of them. All right, so for this next one, we are in radians. We are bounded again, so we don't have to worry about that so much. But I need to have a little bit more work involved for solving these things. So I'm going to start by just multiplying both sides by cosine of x, which will give me 2 cosine x squared, or cosine squared x, I should say, minus cosine x is equal to 1. Subtract the 1 over 2 cosine squared x minus cosine of x minus 1 equals 0. This thing factors. All right, I follow the same factoring rules I did when I first learned how to do it. So since I have 2 cosine squared, the only way I can get a 2 is a 2 and a 1 multiplied together. The x is just cosine of x now, basically. Since this is a minus sign, I'm going to have a plus and a minus, but the only factors of 1 are 1 and 1. So since this is a negative, I need the outside to be bigger than the inside. So that means I'm going to have the negative there and the positive there. So the outside would be negative 2 cosine of x. Inside would be positive 1 cosine of x. They will FOIL to give me that. So now 2 cosine of x plus 1 equals 0, or cosine of x minus 1 equals 0. On this left one, I'm going to subtract 1 and then divide by 2. So x is going to be cosine inverse of negative 1/2. That's 2 possible values. It's in quadrant 2 or quadrant 3, and we are in radians. So x is going to be 2 pi over 3 or 4 pi over 3. Now I'll come to the other equation. Cosine of x equals 1. So x is equal to the cosine inverse of 1. Now I have to be careful of my restriction here. My restriction tells me it does include 0 and 2 pi. So x is equal to 0 or x is equal to 2 pi. They are included, so they both work. If I didn't have the or equal to part, I wouldn't be able to include one of them, depending on what the situation was. So these are my 4 answers. Because I'm restricted, that's it. If it wasn't restricted, 0 less than or equal to x less than or equal to 2 pi, I would have to add 2 pi k to each of those answers. Now for this next one, we're solving in radians again. It's a little bit trickier because I have sines and cosines. I can't just jump in like I have been and treating it like an x. I need to get everything in terms of either cosine or sine. This is where I use the identities from last chapter. So I'm going to use the fact that 2 cosine of theta is equal to 1 minus 2 sine squared theta. This thing had 3 different possibilities, but the other 2 both had cosine. I'm trying to get rid of cosine, so I want to write it like this. So my new equation is going to look like this. Now I'm going to have to combine all my like terms. So I've got negative 2 sine squared theta plus 3 sine theta minus 1 equals 0, because I had that 1 from out front. Now I like to try to factor, and I never like trying to factor when my a value is 1. So I'm going to multiply everything by negative 1, including the right side, which is 0, so that's not really going to change anything. But what's going to happen is I'm now going to have positive 2 sine squared theta minus 3 sine theta plus 1 equals 0. Okay, I multiply everything by negative 1. You could say you added the negatives over and subtracted the positives over. It gives you the same thing. But by doing this, I get something that I can actually factor. So 2 sine of theta goes there. Sine of theta goes there. Since I have a plus sign, with that c value, it's either plus plus or minus minus. Alright, and since that's a minus there, I know that it's going to be a minus and a minus. Factors of 1 are just 1 and 1. So I factor to this thing. So 2 sine of theta minus 1 equals 0, or sine of theta minus 1 equals 0. Add 1 to both sides on this first one, and then divide by 2. So theta is equal to sine inverse of 1/2. Now, sine inverse of 1/2 has two possible values. All right, we're in radians mode, so I'm going to get that theta is equal to pi over 6, or theta is equal to 5 pi over 6. Okay, it's positive in quadrant 1 and quadrant 2. These are angles in quadrant 1 and quadrant 2. I'm going to have to come back to this one, but I want to find my values for this thing first. So add 1 to both sides. Sine of theta equals 1. So theta equals sine inverse of 1. Sine inverse of 1. The only time that sine of theta is equal to 1 is at pi over 2. That's the only time. The question said find all solutions. So I'm going to actually have theta equals pi over 6 plus 2 pi k. Theta equals 5 pi over 6 plus 2 pi k, or theta equals pi over 2 plus 2 pi k. Where again, k is just counting up how many times you spun all the way around the circle. You have 1 rotation, 2 rotations, 3 rotations. You could have 0 rotations, in which case you get the 3 answers we actually found algebraically. These just give every possible answer if you were continuing to continuously, that's not even a good sentence, but if you just kept going around the circle, you'd be repeating your angles, is what's happening there. Alright, now we're going to use degrees for this next one. This next one, there's a few different ways to solve it. You can make your life easy, you can make your life difficult, totally up to you. Regardless what you do, you need to get both trig functions in the terms of one of them, either cosine or sine. I'm going to use the fact that cosine squared x is 1 minus sine squared x. It's unfortunate timing for that banner to pop up. So what I have is 4 times 1 minus sine squared x plus 4 sine x minus 5 equals 0. All right, I'm going to distribute that 4. Combine my like terms, it gives me negative 4 sine squared x plus 4 sine x. 4 minus 5 is going to be minus 1 equals 0. Kind of the same trick I did last time. I'm going to make this a positive 4 sine squared x minus 4 sine x plus 1 equals 0. You can say you're multiplying everything by negative 1, dividing everything by negative 1, just adding it to the other side. Now this one also factors. It might be harder to see what the factors are right away because 4 has either 4 and 1 or 2 and 2. Generally, I like to jump right in the middle and just test out the middle factors first, kind of see where I'm at, especially since this b value is the same as the a value. I'm going to be able to get this. Now, you could rewrite this as 2 sine x minus 1 squared. I don't really care that much, because either way, you're going to get that thing has to equal 0. I don't have to do an or because this is the exact same thing. Add 1 to both sides. The sine of x is equal to 1/2. Remember, sine of x or sine of theta equals 1/2 is in the positive quadrants of quadrant 1 and quadrant 2. So x is equal to, since we are in degrees for this one, that's 60 degrees. No, it's not. I lied to you there. I'm sorry. That's going to be 1/2 at 30 degrees. I was thinking cosine for some reason. Plus 360 degrees k. Or x is equal to, instead of 30 degrees in quadrant 2, I take 180 minus 30, which is 150 degrees, plus 360 degrees k, since we're finding all possible solutions. Now remember, you need to know your unit circle. If you don't know your unit circle for these things, these problems are going to become increasingly difficult, but you can always do your special right triangles. Okay, if I'm trying to figure out what that angle measurement is and it equals 1/2, right? Opposite over hypotenuse, this becomes square root of 3 right there if you need to define cosine for some reason, but that is a 30, 60, 90 right triangle. Number 4 here, there's a small typo. It should say equal to 0, but it doesn't, so make sure you make that change before you try to solve it. Otherwise, you're kind of in for a world of hurt. I'm going to start this problem by factoring out a sine. If I factor out a sine, factor out sine of theta, not just sine by itself. This first term becomes 2 cosine of theta minus the second term is just square root of 2 equals 0. Now I have a sine and a cosine each. I don't need to actually change these because I've got it into something times something equals 0. So either sine of theta equals 0 or that second term equals 0. You can go through the process of getting rid of cosine and writing it in terms of sine. I've done that actually. You have to use a few different identities. It's a whole lot of extra work that you don't really need to do. So this first one, sine inverse of 0, we're finding all solutions in radians. Okay, sine of theta equals 0 at 0 radians, pi radians, 2 pi radians, 3 pi, 4 pi, etc. So I could say theta equals 0 plus pi k, or you could just put pi k radians. If k equals 0, 1, 2, 3, 4, 5, doesn't really make a difference. You'll be on that far left or far right side of the circle. The other one over here, we have a little bit more work to do. Add square root of 2 to both sides, divide both sides by 2. So cosine of theta equals the square root of 2 over 2. So theta equals cosine inverse of square root of 2 over 2. You've got two possible values here, right? Cosine is positive in quadrant 1 and quadrant 2, and I know that's a 45-degree angle, but I'm supposed to be in radians. So that's going to be pi over 4, and I'm just going to put plus 2 pi k. That would bring me all the way around back to quadrant 1 each time. Or if I subtracted pi over 4 from 2 pi, that would bring me down into quadrant 4. And that becomes 7 pi over 4. I'm going to add 2 pi k. So I've got three possible values here. These two I put plus 2 pi k because I said this specific angle in quadrant 1, spin all the way around the circle, come back to that specific angle in quadrant 1. Same thing here, but in quadrant 4. This one only has 1 pi k because I'm just going back and forth. Okay, far left, far right side of the circle. If you put plus 2 pi k, you are going to have to write two values of theta. You would have to write theta equals 0 plus 2 pi k, or theta equals pi plus 2 pi k. It's more writing, but this encompasses both of those. All right, there's your homework assignment. I hope everybody has a great day.